This is the Snow Melt basics from HBX. So what we'll go over, like I said earlier before we had technical difficulties, is just the basics of snow melting and how our controls integrate into the snow melting out there. So we'll talk about the Snow500, the Snow-0110 a little bit, and then how to mount and use the Snow-0110 Snow Melt sensor. So obviously snow melt basics, you guys probably have a half decent understanding of snow melting. So where you can use snow melting is driveways, ramps, obviously walkways, different parking areas, stairways, loading docks, and we've had some instances where they use them on the car washes. So they use these on the exiting side of the car wash so that obviously when the car goes out and it's wet and up here it can get down to -40, the water will freeze fairly quickly, so they don't want, any accidents or ice forming outside of those car washes. So it's a good place for it. So it doesn't matter if it's electric cables, so resistive heating, or if it's hydronic heating. It doesn't matter. It's the same principle for the snow melting. So how a snow melt system works, like I said, you guys probably know this information, but we'll go through it based on how our systems would melt snow. So this is a basic injection system. So we have the snow melt sensor out in the slab somewhere. We've got a system pump, an injection pump, and some sort of heat system. So we would start out at idle. So when there is no snow detected, we'll set just an arbitrary number of 28 degrees. So when the system is idling, it's targeting this slab to be 28 degrees all the time. So that's below freezing, so it doesn't cost $1 million to heat the slab all the time. But when you do use an idle temperature of 28, it will recover fairly fast. So it won't need a lot of time to go from idle into melt mode. So then if we get a little bit of snow on top of the snow melt sensor, we come out of idle and we go into melt mode, which takes us to a new melt temperature. So what this does is it raises the set point of this slab from 28 degrees to 50 degrees. So now it comes out of idle mode and into melt mode. The snow goes away, we go out of melt mode, and we go back to idle mode. So there is a time frame in there that you can set, and we'll talk about that as well, so that when the snow does go away, there is a melt time that will run after it stops seeing the snowfall. So once again, if you guys have any questions or concerns or whatever during this presentation, just don't hesitate to throw out a question. So just some of the terminology that we'll use and some of the terminology that HBX uses when we're talking with customers and in our information is intensity settings. So these are something that differentiates us from all of the other people out there because of our snow melt technology. But we've got instant intensity, and basically what that says is if the snowfall is ever greater than that setting set in the Snow500 or Snow-0110, the snow melt control will come out of idle and into melt mode. Constant intensity works sort of on the same principle, but it's over a long period of time. So you can actually set the snowfall rate, let's say at a 10%. If the snowfall rate stays at about a 10 or 15%, for a period of time, that will also accumulate snow on the ground. So we want to also come out of idle and into melt mode in that instance. So you can set those two parameters. And then the idle temperature obviously is the slab target when there's no snow present. So this can be either 28 degrees, 26 degrees. If people don't want to idle the slab, obviously there's a longer recovery time on there. The melt temperature is the slab target when snow starts falling and the snow melt control goes into melt mode. Melt time, this is the amount of time that after there's no snowfall that it will stay running to obviously clear the slab of all of the snow. Warm weather shutdown, cold weather shutdown, those are, well, we'll go over them. They're not always self-explanatory. Warm weather shutdown is when the outdoor temperature gets too warm that obviously it will melt the snow on its own. We don't need any hydronics to melt the snow at that time. Cold weather shutdown depends on how the system has been designed. So if the system's been designed only to work only to produce enough BTUs at, let's say, a minus 10 degree outdoor temperature, then it doesn't matter how much BTUs you try to put into it, the system will not actually warm up the slab below 10 degrees or minus 10. So you would set your cold weather shutdown at, at that minus 10, because you don't want it to work down there, because obviously it's never going to melt the snow anyway, so it will continue to run and run and run and waste a lot of money. So the SNO-0110 optical sensor is really what sets us apart in the industry. So it's the only optical sensor in the industry. So what that allows us to do is we can, like we talked about before, have multiple intensity settings. So you can tune the snow melt system for the installation. So it's polycarbonate, so it's the hardest plastic you could buy. It's scratch resistant. Nothing is scratch proof, but when we initially designed this, we did a lot of tests with scratching and gouging and running over it and rocks getting on it and all sorts of stuff. So it actually, in a sense, sees around all of the scratches or through all of the scratches. So scratches and debris on the unit doesn't interfere with the way that it senses. So also salt doesn't affect it. So it's not like a brass sensor where you have to scrape it and use a wire brush once a month, or you lose your warranty. This is, like I said, it's polycarbonate, it's plastic, so it doesn't react with salt. So it's got an integrated slab sensor into it, and it comes with 100 feet of sensor wire, 3-year warranty on it. So that's, like I said, that's what really sets us apart in the snow melt industry. So this is just a quick graph of a few years ago, some snow melt sensor readings that we did. So you can see on the graph that basically it's sensing a little bit of snow under 10%. The snow goes up a little bit. It starts messing around, and then we actually had our sensor, our intensity setting set at 30%. So it was at this point that it came out of idle and went into melt. If we had continued only with a little bit of snow and it went off, then we wouldn't have actually went into melt mode in this case. So we would have saved a lot of money just from this period of time. So these are your potential savings from basically when it's only seeing small amounts of snow in this case, and it's not reaching your intensity settings. This also applies on the back end. So we'll know the instant that the snow stops falling, and then we can work from there to basically shut the system down properly. So the SNO-1000 was our first snow melt control. Basically the SNO-1000 is like the Tecmar 664 and the 667, I believe. There was a lot of demand back then for fully integrated snow melt systems that would run boilers, that would run pumps and do all sorts of stuff. And obviously you guys know that the industry has changed with the advent of all the modulating and condensing boilers, that there's no such need for such big controls anymore. So, but we'll go over this control a little bit. So one of the big differences between this and the smaller system is color coded and keyed terminal blocks. Obviously very easy to wire, so everything's line neutral ground in. So your pump outputs, these actually have 120 volts coming out of them for pump outputs. Intuitive and easy to program, so everything's in plain English, so it's really easy to program. 4 buttons, programs just like our CPU 1000 and our Eco 1000. So if you know those products, you'll know this product very easy. So comes with the snowfall settings, so the instantaneous snowfall settings. So like I said before, if the snowfall rate outside goes above the instantaneous setting, then it comes out of idle and into melt mode. Same with the continuous snowfall rate. So if we have a small snow rate for a long period of time, it will also come out of idle and into melt mode. Has things like viscosity compensation, 2-zone operation, so it has a slab zone, or a snow zone and a slab zone. Adjustable delta T's, so you can adjust boiler delta T's, system delta T's. Can go up to 10 on-off boilers or 5 modulating boilers. Obviously the slab sensor is integrated into the into the Snow-110, warm weather shutdown, cold weather shutdown, and multiple injection or valve control. So we can do injection, pumping, we can do three-way, four-way valve injection, modulating injection. So there's a lot of different opportunities for different snow melt systems. So the Snow-1000 needs the Snow-100 module to basically make it into a snow melt system. So the Snow-100 is where we tie our snow sensor into, and our return sensor and our second zone sensor if we're going to be using that. So it needs to have power on it, obviously, and it has an output on it for a floating action valve as well. So it connects to the Snow-1000 with a 32-pin connector along the side, and it just basically connects straight across, and then you have a full snow melt system. So the Snow500, when we developed it, basically took 90% of our Snow-1000 sales, because at that time people were not looking for the big snow melt systems anymore. They were looking for something that just basically gives a boiler on-off output to talk to some condensing or modulating boiler system, or a larger system where it can just turn on a pump at that point. So the Snow500 is still a standalone control. It doesn't need any modules. It doesn't need anything extra. It's just the Snow500 is what you need for the snow melt system. Obviously you still need the sensor, but as far as controls, it's just the Snow500 only. So single dial operation, multicolor backlit display. One thing I will tell you is that this is going to be changing probably in the next 3 months. We're going to a new style control, and I'll show you that at the end of the slides. So it has all the same features on it as Snow-1000, the snowfall intensity setting. So we have the instantaneous snowfall setting, the continuous snowfall setting. Obviously it uses the optical snow technology. Integrated slab sensor is also still built into that Snow-110. You can have injection mixing or floating action mixing, warm weather shutdown, cold weather shutdown. So it has all of the features that you need for your basic snow melt systems that 99% of people are putting in now. So 2 sensor inputs, so 10K sensors. So you have a system sensor, you have an outdoor sensor, we have a boiler output, we have the actual snow melt sensor, our pumping outputs, and then 120 VAC in, obviously. Like I said before, single dial operation, so it is fairly intuitive to use. The one downfall about the Snow500 over the Snow-1000 is that it does only show one parameter on the screen at a time. So when you go through the parameters, you will only see one at a time, which compared to our 1000 series controls is a little bit of a downfall, but this control is far less expensive than the 1000, so we do sell a lot of them because of that. So this is just a quick overview of the screen. So like I said, it's a single parameter screen, so it is an icon based screen. So up in the top we've got a set mode, status mode. If we're in programming, basically indicates snow, instant, constant, warm weather, and cold weather shutdown is this arrow. Here's your temperature reading, and then it'll actually give you the snowfall rate here as well. And then the 1, 2, 3, 4 across the top is obviously if we have boiler demand, the injection pumps on, system pumps on, or the heater is on. So these are things that we will ask you if you phone in. We will ask you, what numbers does it say on the screen as far as up in the top left-hand corner, because we want to know if the boiler demand's on or if the heater's on, because that's very important. So the backlit display, obviously light blue, there's no demand. It's kind of a whitish light blue. Dark blue is when we're in idle mode, and red is when we're in melt mode. So you can see right away when you're looking at the control what mode it's in. So we will ask you if you phone in what color the screen is. So a couple of the screens, obviously when you're in status mode, it's going to say status on the screen. So that little icon will indicate the status screen. So a couple status screens that you might see is the low temperature system target. So that would be system temperature, and then we would have status, low temperature system, we would have system temperature and then status, outdoor temperature, out temp -10, obviously. So these are a couple things that we would get you to scroll through as we're maybe helping you troubleshoot the system. The demand input. So these three parameters are probably, if I was to pick three parameters that are the most confusing on the control, it would be these. So what this allows you to do, the demand input. So we have a demand input on the Snow500 that can do a few different things when you're in the different modes. So when you're in demand 0 mode, basically you're going to always be in idle unless you're in warm weather or cold weather shutdown. So what that allows you to do is it frees up that demand terminal for a forced melt demand. So some instances you might have somebody set the instant intensity to 50 or 60%, so they don't mind shoveling their snow off their driveway once in a while. So it'll accumulate on there up to a 50 or 60 or 60%. But if they actually don't want to go out and shovel the snow, they can have a push button on there where they basically push the button and it'll go into force melt. So it'll instantly go into melt mode. And DEM1 is basically that same demand input. If you're in DEM1, basically turns the control on and allows it to go into idle mode at that point. So you lose the forced melt demand when you're in DEM1 because you're using that as an on-off switch for the control. So that allows the user, if they're away for long periods of time, when they come to that house, they can just turn the control, flick the switch, turn the control on, so that once they're there, then it'll start looking at the optical sensor to see if there's snow, and then it'll go from idle mode into melt mode. DEM2 is basically for BMS systems. So what this allows you to do, it's the same as DEM0, but the output for the boiler demand only turns on when you go into melt mode. So what this allows us to do is talk to BMS systems to basically interface our system to the BMS system. So keep in mind that if we are still controlling any of the pumps or the system temperature or anything like that, you still want to be in DEM1 or DEM0. This is only if the BMS system has full control over the system. So we don't care what the system temperature is. We don't care about anything but the snowfall. So once we see snow, we click the boiler output on, which would go to your BMS system, which would basically tell them to do something with the slab that we're seeing snow. So they would control the idle temperature, they would control the melt temperature. All we would be telling them is that we've seen snow. A couple example applications. So injection mixing, like I said. So boiler pump is connected to the boiler. We would run the injection pump and the system pump. System sensor would be attached somewhere before, not on the return line, but on the outgoing side. So as you can see here, we got a little forced melt demand. We have the system sensor and the outdoor sensor. This connector would go to our boiler. We have our snow sensor, so we can see the injection pump, the system pump, and then basically we have the 110 going into it as well. So for that application, for setting it up, you need to make sure that you set up your mixing type to IN. So there's FLO or IN. So you need to set it to IN, which means it's injection. So that will actually that is the default for the setting for the control. So if you're using it for floating action, then you would actually change that. Otherwise, that is the default. Minimum slab temperature. So this is the idle temperature. So minimum slab temperature is your idle temperature that you would set. So like I said, you can set it around 25 to 28 if you want it to be quick reacting when it does see snow, or if somebody doesn't want to pay for idling the slab for 90% of the winter, then you would set this really low. So let's say -20. So warm weather shutdown, most people set it to around 36, 38. Cold weather shutdown depends again on how you design the system. Floating action, so here's just a little bit different system. So you can see boiler pump is connected to the boiler. We're running this floating action valve system sensor. So we've got a relay in here in this case to run this pump, or you could run the pump in a different way. We've got the boiler connected here as well, and then the floating action valve. So we've got the force melt demand here is again the system sensor and then the outdoor sensor. So in this case you would set your mixing type to FLO. Obviously we can have a system delta T in there as well at 25. So what the system delta T does is makes it so that you're not cracking the slab. You don't want to put 135 degree water to a slab that is sitting at only 25 degrees because you would have basically 110 degree delta T and you'll end up with big cracks in your concrete. So that's something we want to avoid, and that's why people put snow melt systems in. So minimum system temperature. So obviously there's a minimum system that you would put out to the driveway or the snow melt system. So you can set that to whatever you want. Most people set it around, 70 or 75 maximum system temperature. So obviously once you start getting over 135 degrees in concrete, you can start hurting the concrete. So 135 is about the maximum you would want to put out to a snow melt system, but once again it's based on the delta T. So it's going to do, in this case, if the return temperature was coming back at 50, we would be outputting 75. If the return temperature was coming back at 100, we would be outputting 125. So it will go based on that delta T, so it doesn't crack the slab and it warms up accordingly. Like we had talked a little bit before about the intensity settings. So this is the instant intensity setting, and we could set this at anything from, I do believe, 5% is the minimum, all the way up to 90% or 80%. But most people would run this around, if you want it to react very quickly, you would set this at 5%. So if the snowfall rate goes over that 5%, then it will react and go out of idle mode and into melt mode. If you want the system to react a little bit slower, so you don't mind if it snows an inch or two before it turns on, you could set this at anywhere from 30 to 60%. It's okay. The constant intensity is the same thing. So if the person has set the instant intensity up in the, let's call it the 50% range, then the constant intensity would also help them out, because what the constant intensity does is it allows the user to set a setting so that if it does snow consistently for an hour or two, you are going to have a buildup on the driveway. So this will also bring the control out of idle mode and into melt mode as well. So this constant intensity setting is used in conjunction with the time. So in this case we've put 3 hours. So if it snows at a rate of 10% for longer than 3 hours without going over the instant intensity setting of if we set that at 50%, then it will come out of idle mode and go into melt mode. Keep in mind that a snow melt control is really just a control that changes the set point on a slab. So when it's idling, it might just idle that slab at 25 degrees. So it's always going to keep that slab at 25 degrees Fahrenheit. And the only difference when it sees snow is it raises the target of that slab to, let's call it 45 or 50 degrees to melt the snow. And then once it stops seeing snow, it goes back down to the idle temperature. So it's just it's just something to change that set point on that slab. So installation is a big part of any snow melt system. Obviously we won't get into the mechanical side of it. We will just give you the ins and outs of how to install our system. So we've had a few issues with installations on our snow melt system. One of the biggest ones was people were cutting the wire on the SNO-0110 sensor. So do not ever cut the wire on the SNO-0110 sensor. If you need to extend it, you can extend it, no problem. You can go up to about 200 feet. Use 18 gauge to extend it, and if you can, use 2-pair shielded. One thing that we don't want you to do is we don't want you to run the sensor wire by any high voltage wiring, because it's a digital feedback that we get from that sensor, so it might impair the sensor readings, that's all. So once again, do not shorten the sensor wire. You can make it longer, but do not ever shorten it. So if we get a snow melt sensor back to us that has been shortened, the warranty is instantly voided. So keep that in mind. So one of the other problems that we found people weren't doing is they weren't doing proper drainage on the control. So let me go back to the shortening of the wire. So we do put a sticker right on the top of the snow melt sensor now, right on the face of the sensor, that says "Do not cut the wire." So we've gone to great lengths to make sure that people don't shorten the wire, because, like I said, it can wreck the control. So the second one was drainage. So we had some instances where people would not drain the snow melt socket, and this would fill up with water and then freeze. And you know what happens when you have something filled up with water and it freezes. Basically it will crack and wreck the sensor built into here. So it's actually epoxy filled. So what happens is it will actually break this sensor, and it will wreck it. So we tell people to drill in the bottom of it. We actually do put a sticker now in the bottom of the socket that says "Drill here," so that people will obviously drill it out and make sure that they have proper drainage out the bottom of it. So slab sensor location, obviously you don't want to be too close to the pipes in the slab. Obviously it will affect the sensor reading. So if you in fact have located the sensor too close to one of the pipes, you'll get a bad slab reading. In that case, you could use the remote slab sensor technology built into this, so that you can actually take the slab reading from another location. You don't necessarily have to use the slab reading in the actual sensor. And then obviously for ramps, you want to be probably down at the bottom of the ramp where the water would collect, and that would turn to ice, obviously. We want you to mount it so it's flush on the top. We don't want you to have it below grade, because water will just collect inside of it, and we don't need the water to collect inside of it, because we can detect snow very, very accurately when it actually hits that sensor. So we don't want it to collect on there, because we might see it as snow. So obviously mounting it, we have 4 mounting locations where you can put rebar in, so you can level this to grade. Obviously if you some guys put insulation, put the sensor right on top of the insulation. Just make sure that you pop a hole through the bottom of that insulation so that you got proper drainage. Also, I'm not sure how you guys put your wiring in, but we have a lot of guys using just PEX or conduit out into the slab, so that you can run the wires easily out to the slab. So I do not recommend running the wire straight in the slab and then pouring concrete around it, because if something did happen, you would never be able to get the wire out, which is generally a bad thing. So when you're installing this as well, there's 4 brass plugs on the outside of the socket. So make sure that those brass plugs are in place, and when you push the sensor down into it, make sure that those are pressed in. So that what that does is that gives us contact from the slab to the slab sensor built into the actual SNO-0110 optical sensor. So if those aren't touching properly, or if those aren't in place, then we'll get inadvertent readings on the slab temperature, and the system won't work properly. So one of the big things about this sensor technology is you can remote mount it. So what that allows us to do is you don't necessarily have to put the SNO-0110 sensor in the slab. You can put it in a flower bed, you can put it beside the driveway, we've had some people put it on a roof. But all you have to do basically is you would have a remote slab sensor that's in the slab. So that's just basically the slab thermistor would have to be in the slab, so that we can still know the slab temperature. So the SNO-0110 sensor would let us know when it snows, and the remote slab sensor would tell us basically what the temperature of that slab is, so that we can run the system properly. So one thing that we do definitely recommend, if you're using paving stones or something like paving stones, that you use the control in the remote sensor application. So you can still mount the optical sensor in the driveway, we just recommend that you don't use the slab sensor built into the optical sensor because there's not enough mass around it to work properly with the sensor. So we recommend that you basically just drill a hole in the side of one of the paving stones and put a remote sensor into there. So when you're doing that, basically the difference is it'll in the settings you would have a slab sensor. This indicates that it's an internal, so you're using the slab sensor built into the optical sensor, and this is how you'd hook it up. So you'd have green, red, white, black, and the shield wire. So you need to make sure that you hook up the shield wire as well, because we do use the shield wire as a full wire on the optical sensor. If you're remote mounting the optical sensor, or if you're using it in paving stone application, you would make sure that you set it to the slab sensor to REM, which is remote. So what this does is you now don't need the white wire from the optical sensor, and you don't have to hook the shield up, but your external slab sensor would get hooked up in these locations. So 9 and 10 would be where you hook up your external sensor. And the Snow-110 optical sensor does come with a spare slab sensor. So if you do want to remote mount that slab sensor, it does come with it. And just this year we've started rubber coating those slab sensors so that they are very, very water resistant already. But we've had some instances where those slab sensors have failed over time, and we're just always trying to improve our products so that we now rubber coat those so that no water or no moisture or the elements won't affect that at all. So that's it basically for the Snow500 and the Snow-1000, and talking about HBX and snow melting. Basically what this is our new snow melt control coming out probably within 2 to 3 months. So we've basically changed the way that we our interface on the Snow500. So this will be the Snow550. It'll be a 3-button interface excuse me, and it'll program more like the Snow-1000. So it's not an icon display anymore. It's going to be the same display as our thermostat. So it'll be a lot easier to program. You'll be able to see everything that's on the screen all at the same time, and it'll take the Snow500 basically to the next level where we want it to be. So it'll have all the same features as the current snow control. Better fusing on the sensor side, so that if we do have sensor failures, there will be no chance of the Snow550 getting hurt, things like that. So we're going to upgrade the hardware on the Snow550 and the interface to make it a far better control. And the price point will stay the same. So this isn't going to change the price point at all, which is a good thing. So that's it for the snow melting from HBX. I'm not sure if you guys have any questions. If you want me to go over anything else, I'll wait around a couple minutes to see if you have any questions. But other than that, thank you guys for all attending, and that's it.